And again, review what we've been thinking about so far. If we have something squared and we can get it by itself, then we can square root both sides. However, sometimes, like in this example, when you get it by itself, you have something squared equals a negative. And you see that that will never happen. If you get something squared equals a negative, that's going to be impossible, and we're going to say that it has no real roots. But sometimes you have something squared, right? You have something squared, but you have another x in the question. You have an x squared plus 6x equals 16. And what we're going to do with this, because we're going to go till it shows up with what you have. Right. There we go. This is where it starts for you. And we're going to learn something called completing the square. One of the things that we notice is that sometimes if you have something squared, like x plus 3 squared, and you multiply it out by doing x plus 3 times x plus 3, if the numbers are the same, does it make sense that you would have x squared here, 9 would be your last one for sure, and in the middle you would have 3x plus 3x twice, 6x. And that this number here will always be double that number if it's happening twice, because my outside and my inside will be the same thing twice. 3x once, 3x again, 6x. That is going to be an important observation because it will be our hint. Right now, I have x squared plus 6x equals 16. What I want, and I'm going to put a space here, I want this plus 9. Should have a plus sign there. I want that plus 9 there because then this is perfectly x plus 3 squared. And the 6 is giving me the hint that I want x plus 3 squared. And because I want x plus 3 squared, I'm going to get a 9. So I add 9 to this side. But what happens if you add 9 to one side of the equation? It's no longer equal. Does it make sense that I also have to add 9 to the other side? What this allows us to do is to rewrite this as something squared equals 25. Okay? Now, this one, if I now square root both sides, I'm going to get plus or minus 5. And then if I move the 3 over, I have x equals negative 3 plus 5. So that means x could equal 2. And I have negative 3 minus 5, which means x could equal negative 8. Now, you might argue, well, Mr. Jarrett, we just did these last class, and you showed us a different technique. Do you remember the technique we had last class? Where if you're solving a quadratic equation, you should, and I'll do it over here, make one side equal to 0. So I'll subtract 16. And then factor it. Do you remember that? So in this case, it factors nicely to x and x, 8 and 2. The 8 would have to be positive, the 2 would have to be negative. And so using our big idea of the zero product property, x could be negative 8 and x could be 2. However, there are some times that factoring is not possible. So in this technique, if I gave you this question, I probably would like you to factor it because it works out really nicely. Okay? But now we've got a new technique that says if we complete the square, and completing the square is making something a perfect square, then we can square root both sides. So if you want to highlight this technique is called completing the square. And it's nice for examples that cannot be actually factored. So that example we looked at could be factored. Ooh, I like this one. It looks like we should be able to factor it. But miserably it doesn't work. Okay? So this is what I would first try. If it could be factored, would you agree this has to be x and x? Guaranteed. And if you have 3, it has to be 3 and 1. And everything is looking good right now because it just so happens that 3 plus 1 equals 4. So you're very optimistic at this moment. Okay? And what do I need? I need a plus 4. Does it make sense that the only way I could get a plus 4 is if my outside was plus 1 and my inside was plus 3? Do you see the problem though? Because if I double check, my last ones aren't minus 3. Oh no. So I tried to factor and it does not work at all. So now we go to this next technique of completing the square. And what we're going to do is we're going to keep the x squared and the 4x together. And I'm going to move the number to the other side. And this 4 is the hint. In fact, in showing the mathematics for this, it's actually interesting because we don't do it in a normal order. In other words, what I'm going to do next is I'm going to use that 4 as a hint and say, I want to write this as something squared. The only possible way I could have something get a 4x if it's squared is if there was a 2 here. But unfortunately, is x plus 2 times x plus 2 x squared plus 4x? No, it is x squared plus 4. It's so close, but it has this extra plus 4. So I'm going to draw a space right here and say this would work if I had a plus 4 there. But if I add 4 to the left side, I also need to add 4 to the right side, which would mean I have 7 on this side. So we use this as a hint to go down and say this has to be a plus 2. Okay? And it will always work out that that hint is going to be half of that number, because when you multiply it out, you get 2 of them put together. So the opposite of putting 2 things together is cutting them in half. And then that, knowing that that's a 2, that gets us back to that space. Because if I have x plus 2 times x plus 2, my last ones has to be a plus 4. So I need to add a 9 there, which means I also need to add a 4 there, I also need to add a 4 there. And what I have successfully done is got something squared, which I can now get rid of by square rooting both sides. And remember, when you square root both sides, it could be positive or negative. And this is why I couldn't factor, because there's a square root of 7 in our answer. And that's not normally part of our mental math, right? When we factor, we like nice numbers, whole numbers. If it's not whole numbers, it makes it difficult to factor. So now I can get x by itself by subtracting 2 on both sides. And I guess this, you don't have to write this down, but for those of you that like weird technicalities, technically you could have used this answer and had x minus this to negative 2 plus root 7 over 2. No, there's no over 2. Right? Let's just rewrite it. If I wanted this answer I would have to have it -2 plus root 7 there. And my other answer would be x minus -2 minus root 7. And if you multiply that all out, it works out perfectly to be x squared plus 4x minus 3. But is there any way you would think of using those two numbers when factoring? Absolutely not. They're like, oh, it's on the tip of my tongue. I think it's going to be 2 plus the square root of 7. Oh no, it's -2 plus the square root of 7. No, you'd never be able to factor that. But if we complete the square, we can easily square root. And that shows us what weird number is the answer. And we can get x by itself. And here are two solutions. Do you see there's two solutions? One's with the plus, another solution's with the minus. Okay. So try it. Some of these ones, 5, 8, and 9.